Welcome to section 7.1. We're dealing with solving systems of equations, and we're going to give you a brief overview of the type of stuff we will cover in this chapter, and then we're going to get into one type, and we're going to be doing substitution today. So take a look. We have an equation 2x plus y equals 6. As we look at this, we know that there are two variables that are unknown, the x and the y. How many solutions does this equation have? Well, this, if we look at it, we know is linear. Therefore, every line has infinitely many solutions because there are infinitely many points on the line. If I pick one of them, let's do the point 1, and if I plug in a 1, 2 times 1 is 2, plus 4 has to get me 6. So the point 1, 4. Now we're looking at other points, and I'm doing this so that we can see if I add another equation how it works. But take a second and plug in these points. Plug in the x, find the y. You should get 0, 6, 1, 4, 2, 2, 3, 0, and 4, negative 2. Okay? Now we're going to add another equation to this 3x minus 2y. This is called a system now because there are multiple equations. So we have two equations, still the two unknowns for x and y. Now, how many solutions does this system have? Well, we're talking about two lines, and we know that two lines will intersect at one point, therefore we have one solution. And so solutions are basically the points of intersection. Now, what I want you to do is go above and try these points here. Do any of these work in the second equation as well? Once you plug this in and you found that 3, 0 is another point where if you plug in the 3 for the x and 0 for the y, you do get out the value of 9. And so this is the one solution for this system. Now, we don't want to have to do guess and check every time or find some values and plug them in. Plus, they're not always going to be nice points. So we have some methods for solving systems. The first method is called substitution. And you did substitution in Algebra 2. So this will be a review. We're covering this in section 7.1. What I want to talk about is the number of variables and if our equations are going to be linear or not as well. Because these are things that we're going to encounter that are different than Algebra 2. With substitution, there are going to be two variables, normally x and y, but we can throw some other things in too. Are these going to be linear? Well, sometimes yes, but also sometimes not. And we'll show you the nonlinear ones today in the notes. The second type we're going to look at as graphing. Okay, so we can graphically solve a system, and that's part of this lesson as well. When you are graphing, we have to graph in two variables. And again, I'm going to say yes or no to linear because we know that our grapher can graph more than just lines. The third type is elimination. This is again a review of Algebra 2. Elimination is what we're going to look at in section 7.2. And this again is a two variable thing. With elimination, it has to be linear for you to use elimination. Because you can't cancel out things unless it's exactly the same x and exactly the same y. So please keep that in mind. The fourth one is our new one. This is called Gaussian elimination. And the reason we add an extra word to that is because we're going to add an extra variable or two. So this is section 7.3, and we're going to add variables to 2, 3, 4, 5. We can add as many as we want. Are these linear? They are linear in the fact of we're going to be working in plane geometry. And so we're going to be looking in 3 dimensions, 4 dimensions, 5 dimensions, things like that. So they're considered linear in a plane. And so this is kind of the overview of the first couple of sections in chapter 7, but we're going to first start with substitution. So let's take a look. There's a method to solving with substitution. The first thing we're going to do is solve one of the equations for a variable, and I always look for a single variable. Okay, so like a single x, a single y, something like that. That's the equation then that you want to solve for. The second thing we're going to do is substitute that equation into the other equation. The third thing we're going to do is we're going to simplify and solve that second equation. And we're going to end up with an answer for one of the variables. And then I'm going to add a new word. We're going to do what we call back substitute. And we're going to back substitute, which really just means plug in. Okay, we're going to plug in our answer that we got on step 3 into the other equation to find the other variable. And always, no matter what you do, you should always check your answer. Okay, we want to make sure that the answer works in both and that we didn't make some sort of mathematical error. So what we're going to do is go back up to the intro. They gave you these two equations, 2x plus y equals 6 and 3x minus 2y equals 9. And we're going to start looking at this and we're going to use substitution. Now I suggested to you in the number 1 that we look for a single variable. Well, here's our single variable. So I'm going to solve this equation for y, and we're going to move the 2x over, so negative 2x plus 6. Okay, so that's number 1. We solve our first equation for a variable. Number 2 says substitute it in. So we're going to take this equation and plug it in for the y in the second equation. 3x minus 2 times negative 2x plus 6 equals 9. And now we're going to solve that equation. So I'm going to write 3 right next to it. If I distribute the negative 2, 3x plus 4x minus 12 equals 9. If I add 12, 7x equals 21, and I divide by 7 to get that x is 3. So we solved and got one of the variables. What we're going to do in number 4 then is we're going to back substitute. So I'm going to put this back into an equation to figure out what it is. And I'm going to actually use this equation right here. Y equals negative 2 times 3 plus 6. Therefore, y equals 0. So my solution, don't forget, this is 2 lines. 2 lines intersect at a point, so your solution should be written as a point, and my solution is 3, 0. Please don't forget, and I know this only takes a minute, you don't necessarily have to write it, but you better check it because we do have extraneous solutions, is you look at this and say, does it work in both? Well, 2 times 3 plus 0, does that equal 6? The answer is yes. And 3 times 3 minus 2 times 0, does that equal 9? The answer is yes. And because we've checked both of these, we know that this is our solution. Okay, now this is the linear version that you're used to seeing in Algebra 2. We want to show you some non-linear ones, so flip to the next page and let's look at some non-linear systems and how to go about solving those. Okay, at the top we want to solve one of those equations. And what I'm going to do is I don't want to mess with the x squared, so I'm going to solve this second one. But you'll notice there's a negative y here, so I'm going to solve for negative y. So negative y is negative 2x minus 1. And the only reason is it's easy enough to plug in because it's already a negative y. So when I plug it in, x squared plus 4x minus 2x minus 1, because that's what our negative y was, equals 7. When you have an x squared and an x, you have to make sure that you set it equal to 0. So I'm going to move the 7 over, and I'm going to combine like terms. X squared plus 2x minus 8 equals 0. From here you have 2 options. You may factor or you can quadratic formula. I'm going to choose factoring all the time. I need a positive 4 and a negative 2 to add to a positive 2. So my 2 factors are x plus 4 and x minus 2, which gives me values of x equals 4, negative 4, sorry, x equals negative 4, make that a little clearer, and x equals 2. Now, I got to find the y values for each of my x's. Okay, so as I look at this, I'm actually going to just rewrite this one real quick then. Y equals positive 2x plus 1, because that's going to be easier to find my y's. If I plug in negative 4, negative 8 plus 1 is negative 7. If I plug in a 2, then y is 5. Now, what this says to me then is I have two solutions. One solution is the point -4, -7. The second solution is the point 2, 5. Now, how can that be that we have two solutions? Well, let's talk about the graph. This first equation is a parabola, and because x squared is positive, it opens up. The second equation is a line with a positive slope, and so it's going to go through my parabola at 2 points, and the 2 points are what we've shown above. So when you look at it graphically, they want you to check by graphing, you should be able to see those 2 points as points of intersection. Okay, so two solutions when you have a quadratic. We talked pre-calc A about the fact that the degree tells you how many solutions there are. That should be something that you keep in mind as well. All right, take a look at number 2. I'm going to switch my color so we don't mix up work. I'm going to solve again for y, and I don't want to mess with the x squared, so I'm going to solve the first equation, y equals 5 plus x. Okay, and I'm going to take this and I'm going to plug it in. So x squared plus, and I'm going to put this in order, plus 5 equals 3, and I'm going to move the 3 over. So I have x squared plus x plus 2 equals 0. All right, can we factor this? The answer is no, because the factors of 2 can never add to be 1 if it's a positive 2. So I have to do quadratic formula. All right, here we go. Opposite of b, plus or minus the square root of b squared minus 4a times c all over 2 times a. All right, as I look at my square root, 1 squared is 1, minus 4 times 1 times 2 is 8, so I get a -7 under my square root. This square root of -7 is an imaginary answer. We're not looking for imaginary answers. We're looking for actual points of intersection. Because I get an imaginary solution, I say no solution because I'm looking only for real places of intersection. Let's talk in terms of our graph. How does this relate to a graph? Well, if I look at my graph, 1, 2, 3, 4, 5, I know this is a line with y-intercept of 5 and a slope of 1. And this, if I move my x squared over, is a parabola that opens down, but a vertex at 3. So it opens down with a vertex of 3. Do you see why then we don't have any solution or any points in common? Because as you look at this, again, there's no points where the parabola and the line intersect. Okay? So these two are easily proved algebraically. The third one, we're going to actually use our graph to do, and I'll show you why. First and foremost, it's a natural log. But if I want to go through and now solve, let me make this a positive natural log. So I have y equals the natural log of x. If I plug this in, x plus the natural log of x equals 2. Well, if I solve for the natural log of x, you get 2 minus x, and if I tried to get rid of a log, because it's a base e, I could do base e to each side, and I have this. And the problem is I still have 2 x's, one in the exponent, one not, and so this is going to get pretty messy. Graphically, it's going to be better for us to go to the graph. So I'm going to go to my calculator, and I'm going to graph 2 different equations. The first is the natural log of x. The second one, if I solved this, would be 2 minus x. And I'm going to use my intersect key, so you might want to pause this a second, and use your intersect key to figure out the point of intersection. What you will find is that the point of intersection, and I'm just going to round to the nearest hundredth, is 1.56, 0.44. Now again, not all solutions are going to be nice, and on the quiz and the test, we're going to tell you which ones you just can use graphically and which ones we want you to show algebraically. So kind of keep that in mind. Just make sure you can get that. If you can't, we'll talk about it in class tomorrow. All right, we've got 2 real-life examples for you. So let's slide these down. And the first thing we're going to do is talk about variables, and then we're going to write our equations, and then we're going to solve them. So Mrs. Japanik starts a t-shirt company with Mr. Wilcox. Startup cost for them was $1,200 for equipment and supplies. It still cost them an additional $4.50 to make a shirt, and they're charging $9 per shirt. So how many shirts do they need to break even? If we're breaking even, what that means is the revenue you take in, the amount of money you make, has to be equal to the cost that you put out. So let's look at it in terms of that. I'm going to say I need to know shirts, and I'm going to use X because I don't like to use T. I think it looks like a plus sign. So first thing you have is X is the number of t-shirts. R, please know these words, revenue, and C is cost. These are important going through because you need to know what revenue and cost are, and we're going to use those quite often. Okay, so let's talk about the two things that I'm talking about, revenue and cost. If I look at my revenue, how much am I making? I'm making $9 per shirt. How much is it costing me? It's costing me $4.50 per shirt plus the initial startup fee of $1,200. So how do I determine if they break even? I go back to the idea that my revenue has to equal my cost. So 9x has to equal $4.50 times x plus $1,200, and I start going through and solving. Now I found through this that x is 267. If you get a decimal, please round because again, you can't have partial shirts. So take a look. The problem is this is a story problem. You need to have a story type of answer. So I would put, we must sell 267 shirts to break even. Oops, to break even. Okay, because it's a story problem, you should have a story answer. Things to keep in mind. So that's the first problem that we're working on. And again, it's the idea of breaking even. Please make sure if you don't understand breaking even, you ask, because we will have quite a few of those. The second example is that I'm talking about paychecks. And as I look at my money, I'm saving $5,200 a year, and I invest it into two funds, A and B. At the end of the year, I get 5% interest for Fund A, and I get 8% interest for Fund B. The amount of interest I earned was $296. So how much did I have in each fund? Okay, so here we go. Let's talk about what we know. I'm going to use A and B because we have funds A and B. A is the amount of money in Fund A. B is the amount of money in Fund B, because that's our goal, is to find the amount of money in each fund. Now, they're talking about two things, the amount of money I put in and the amount of interest I earned. So let's start with my first equation and the amount of money I put in. Well, I put some money in A and I put some money in B, and in total I put in $5,200. In interest, I earned 5% interest in Fund A and 8% interest in Fund B for a total interest of $296. Now we're going to use substitution because all of this today is substitution. So I'm going to solve, and it doesn't matter, but I'm going to find Fund A first, so I'm going to solve for B. So what that means is B equals 5,200 minus A. And I'm going to take that and plug it into B. So let's go through 0.05A plus 0.08 times 5,200 minus A, because that's what we said B is, equals 296. I'm going to distribute this, 0.05A plus 416 minus 0.08A equals 296. And all I'm going to do is start solving. when I divide by negative 0.03, I get that A is 4,000. And again, my goal, because it's a story, is to have a story answer. So we want a story answer. Mrs. S put $4,000 into Fund A. And, well, if I put 4,000 in A and it equals 5,200, then I put 1,200 into Fund B. Okay, and again, this is an Algebra 2 type question. We've done this before, but we want you getting used to the idea of substitution. On the quiz and on the test, we will tell you some of the questions we want you doing substitution, some of them an elimination. So kind of keep that in mind. So that's it for 7-1. Go ahead and start working on the homework before you get to class, and I think you'll feel more comfortable with this because it is a lot of review.